So today some important results that came after having knowing the concept of subsets and proper subsets. Okay, so some important results you should note down. These results will be used later on. So some important results. Number one, that we have already seen, every set is a subset of itself. Okay, every set is a subset of itself. When we are writing the subset of any set, that set will also be included in writing the subset. Okay. Second property that you can prove this property also, the empty set and empty set which is denoted by 5. Empty set means which is having no element, is a subset of every set. Second property. Third property, the total number of subsets. You have given a set and you have to find that you have to write the number of subsets from a set. So then the total number, how many subsets you can write, it depends on the cardinal number. Total number of subsets. Our set will come now. Our set we will study now. Yeah, next is power set. So the total number of subsets and proper subsets of a finite set. Obviously, we can write the subsets of a finite set, not for infinite set. And subsets and proper subsets. Because proper subset, number of proper subset will be one less than that. Proper subset or subsets finite set of a finite set containing an element of a finite set containing n elements. It is containing n elements. Suppose 5, 4, n is any number, natural number, containing n element. How many elements? N element. If a set is containing n element, then its number of how many subsets we can make? 2 raised to power n. 2 raised to power n. And how many proper subsets we can make? One less. That is 2 raised to power n minus 1 respectively. Example I will show you by giving an example that suppose that A is a set of elements A, B, C. So what is n here? N is 3. Number of elements is 3. And we used to write number of elements in set A is equal to 3. How many elements are there? 3 elements. Okay. So how many subsets we can write? So number of subsets. First of all, we should know how many subsets can be written. So number of subsets of set A will be equal to 2 raised to power n. 2 raised to power n. And what is n here? 2 raised to power 3. That means 8. So we can write 8 subsets of A. How? Now see that. I'll write the subsets of, now make the subsets of set A, of set A. Subsets of set A are, first you can take every single element separately. First subset will be A. Yes, correct. A. Second subset B, correct. Third subset C. Now you have to take the combination of two elements, A, B, B, C, and C, A. Okay. So this is how many elements? 1, 2, 3, 4, 5, 6, 6 subsets. Now can you tell me 7 and 8 subset? What will be the 7 subset? Afra and Ryan are giving the answers that I'm asking to you. What will be the 7th and 8th subset of this set? Yes, phi and A. Correct, correct, Ryan. Correct. Phi and ABC. Yes, ABC. ABC is itself a subset. So always it will come to two subsets are always phi, and one will be phi, that is null set, and one will be itself. So this set is included when we are writing the subset. If somebody asks to write the proper subsets, these are the minor mistakes students are doing. If we are asking to write the proper subsets, they will write the subsets all. The proper subset, what are the proper subsets? Means proper subset means subsets which are less than this set. The proper subset, only this will not come. That's why 2n minus 1. The formula is 8 minus 1, 7. So this will be excluded. All will come, this will come, this will come, this will be written, this will be written, this will be written, this will be written, and up to 5. The total, how many? 7 proper subsets. How many? 7 proper subsets. There are 7 proper subsets of the set A. Okay. Fourth point, if, as we have seen, I think already, no, it is not seen. A is a subset of B. If A is a subset of B and B is a subset of C, obviously A will be the subset of C. A is in B and B is in C. Then we can say that A will be in C. Then A will be the subset of C. A will be the subset of C. Okay. Fifth point that we have seen already. If A is equal to B, if A and B are two equal sets, they are equal if and only if, that we have seen already, if and only if A is a subset of B and B is a subset of. So if we prove A is a subset of B, B is a subset of A, then A and B are two equal sets. Okay. Now subsets of the set of real numbers. So subset of real numbers. What will be the subsets of real numbers? Subsets of subset of real, not real number. We should write subsets of the set of real numbers. Subset of the set of real numbers. Real numbers. Yes, correct. Set of natural numbers, set of whole numbers, set of integers, set of rational, set of irrational numbers. As real numbers, all numbers which exist, and real numbers, you know that you have seen in class 9 that real numbers are divided into, broadly, they are divided into two parts, rational and irrational numbers. And rational numbers are denoted by Q, rational numbers. Okay. And irrational numbers are generally we denote by Q dash. Q dash means irrational numbers. Q means rational numbers, but these are rational numbers, and Q dash are irrational numbers that you have studied already. Number one. Number two, these real numbers, all are real numbers. Like if we have the sets of natural numbers, yes, Q dash is the complement of Q, correct? So all other sets which are inside these real numbers, like natural numbers, so subsets of real numbers are denoted by R. Denotation I told you at starting is also given in the textbook. R is the set of real numbers. So first subset of the set of real number is natural set of natural numbers. Set of natural numbers denoted by set of natural numbers, and it is denoted by capital N. So I am writing here capital N. You should understand denoted by N, and where N is the set of natural numbers, and natural numbers starting from 1, 2 in the tabular form. You can write like this. It is an infinite set. It is an infinite set. Real number is also infinite set, but in this infinite set, we will find one infinite set of natural numbers. That is why it is the subset of real numbers. Subset of real numbers are set of natural numbers. Number two, we can also have set of whole numbers. Set of whole numbers. And we have the particular denotation for natural numbers, for whole numbers. So it is denoted by W. So whole numbers starting from 0 to infinity. So this is also a subset of real number. Third, set of integers. You can further divide into positive integers, negative integers. We are taking together all the integers. So set of integers is also a subset of real numbers. Set of integers. And set of integers is denoted by Z. And Z is equal to, we can write this is the set of integers. That means from 0 to right hand side, all positive numbers will go up to positive infinity, and left hand side -1, -2 up to infinity. So like this we can write. This is also a subset of real numbers. Then comes rational numbers. Set of rational numbers are denoted by, as I told you, generally we are denoted by Q. So set of rational numbers, it is denoted by Q. And how will you write? The way how will you write? How will you write this set of rational numbers? Can we write in tabular form? No, we cannot write in, we will write in the set builder form. Q is a set of the numbers in the form of P upon Q. Its definition where P and Q, PQ belongs to integers Z and Q is not equal to 0. Like this, we can denote the set of rational numbers and set of real irrational numbers. Now, set of irrational numbers are denoted by Q dash. That is the complement of this set. Complement will come. The next part will be complement. They will not now because they have not studied about the complement. So, set of irrational numbers. Now, set of irrational numbers. So as I told you, it is denoted by Q dash. And Q dash is the set of all x such that x belongs to real number. All real numbers except rational numbers. Except rational numbers, that means x does not belong to the rational numbers. It does not belong to the rational numbers. Like this, we have to write the set of irrational numbers. Okay, so got it. But one more thing, this is N, W, Z, Q, Q dash you got, and Z is a subset of, proper subset of Q. And hence we got one condition that you must remember that N, natural numbers, is a subset of whole numbers, proper subset of whole numbers, you can see. Okay. And then Z comes, then whole numbers is a proper subset, whole numbers is a proper subset of integers, then integers is a proper subset of rational numbers. Okay. So in diagrammatically, we can represent the set like this. Biggest set is the real number that contains all the numbers in the universe. So this rectangle is belonging to our real numbers. And this is further divided into two parts, irrational and rational. Q dash is irrational number and other one is, this is irrational number. This part is denoting irrational number. Other part is denoting rational number. Okay. And this rational number is again divided into three sets, integers, whole numbers, and natural numbers. So this is the diagrammatically representation of the set subset of the real number. Okay. So we will see intervals now. So interval, why we are taking intervals, I will tell you what are intervals. So intervals is subset of real numbers. when we are using interval and when we are just writing in the form of text, just try to understand. If I will say that n is a set of natural numbers, so we know the exact natural numbers. Means we know 1, we know 2, we know 3, but there is no number between 1 and 2. Like this we can write. But if I will say that write the numbers between 1 to 2, real numbers between 1 to 2. So there is no limit of real numbers between 1 to 2. Suppose on the number line, suppose this is a number line. Okay. Here we have, this is 0, that's this 0, this is 1, and this is 2. If I will say write the numbers between 1 and 2, so we cannot write the numbers between any two numbers because there are infinite numbers between any two numbers. I can show you, but if I will write between 0 to 1, I will say write between 0 to 1. How many numbers can you write? I can write 1 by 2. I can write 1 by 3. I can write 1 by 4. I can write 1 by 5 till there is no end. No end up to infinity. When I will reach to infinity, then 1 upon infinity will become 0. But we cannot say there is no number between 1 by 4 and 1 by 5. Again, between 1 by 4 and 1 by 4, 1 by 5, there are infinite numbers. How? We will multiply 10, 10, or we can make them 5 for the 20. So we can multiply then this by 4 and this by 5. Okay. So these are the equivalent. So, or 40 upon 5 for the 20, 200. And here you will get 50 upon 200. Okay. Now, 40 upon 200 is what? It is nothing but 1 by 5. It is nothing but 1 by 4. Now I can write 41 by 200, 42 by 200. Try to understand. So there is no limit. If I will try to write between these two numbers, we can write. So as that you have seen, if you remember in 9th class, we have done zooming on the number line to represent 1.26262626 up to 4 places of decimal. We zoom like this, and again we have got this number. Okay, again that two numbers zoom. So that zooming is this one actually. If we zoom, there is no limit. We can go ahead. So this shows that one property. There are infinite real numbers between any two real numbers. There are infinite real numbers between any two real numbers, any two real numbers between any two real. So we can take any two real numbers. I told you that I have taken 1 by 2, then I have written between 1 by 5. I can write between these two and so on. There is no limit. So if we don't know where are the numbers, we cannot point out. Here 1, 2, 3, 4, we can find out. Yes, this is 1, this is 2. We can write separately. But if we have to write the numbers between 1 and 2, we cannot write the numbers, exactly numbers. We can say the range. Yes, 1 to 2. So how to write? Now there are two possibilities. 1 and 2 included and 1 and 2 are not included. Means after 1, we are taking after 1. We are taking the numbers after 1 and not 1 and after, before 2. And we can have from 1 and 2 also. So that is called closed and open intervals, semi one side open, that I am telling you. So this, how to write this interval? So this real set of 1 by 2, we can write like this. This is the way of writing interval. This is that. Try to understand the difference between set and interval. This is set and this is interval. The interval is written like this, and interval will have the two types of bracket. This one shows that included, 1 and 2 both are included. 1 and 2 both are included, and this is in terms of set. We will write this is the set of all x such that x is greater than 1 and less than equal to 2. This is interval, but it can be written, so every interval can be written in two types. And but there are four possibilities. Both numbers are included, both numbers are excluded, one is included, two is excluded, two is included, one is excluded. So there are four types of intervals. So how to represent on the number line? If you have here, uh, I have included 1 and 2 both. Both are included here. Okay. So when you are going to show the included interval like this, you can write, and in on the number line, you can show on the number line also. How? You can show on the number line also. This interval can show on the number line. Huh? How? It is included. So what we will do at 1, we will make a big like this. We will make one circle on 1 and on 2 also. On 2 also. This 2, this is 1. And when both are included like this interval, I'm showing this interval 1 and 2 in which 1 and 2 both are included, then we have to darken this with any color. We have to inside just darken this circle. Fill this circle that shows that it is included. When it is not included, we will not darken. So next time we will continue about this interval. We have only 1 minute left, so that's why we cannot continue. Tomorrow, inshallah, we continue.